Alright, time for the DraftPhysics.com, debatephysics.com. Also, video presentation, but really can't show you much rational physics video. The naysayers, the nitpickers, the trolls, the morons that want to defend the faith, so they just keep coming up with their little magical simulations of Jesus walking on the water. And, it's my job to point out how, well, they're despicable liars and cheaters, so, no real point in doing that, paying any attention to them. But whatever, since it's the only game in town, it's the only game I can respond to, because the real physicist won't show up. Alright, so this, I guess I'll do some, just some personal stuff. So, about an hour and a half ago, there was an earthquake here, 4.8, not insignificant. But fortunately, I'm living further away from the fault. I used to have the fault used to be in my backyard, literally. I mean, it was less than a quarter mile away, and it was a big fault, where, the ground was like 150 feet, where it just slid, And so I wonder if my little cottage, how it did. It wasn't centered there, but I mean, that was the same fault it was on, the earthquake. So it would be interesting to know. So anyway, it's the first time I was in an earthquake when I was in a house. So I was in this basement, and it really was a little spooky. I've been in outside earthquakes, and it's like, okay, it's a little bit funky. You feel like you got a blood sugar problem or something. Then you figure out, oh, it's the ground doing that. So anyway, so it was interesting, gotta say, just interesting. Then yesterday, this weird shit started happening with my browser, Firefox. Complete failure. So if I open something in a private window, which I will show here, I guess. Yeah, so that's a private window in Firefox. I get the whole YouTube experience. But if I open this, yeah, that doesn't work at all. That's not the page, though. There it is. Okay, so this is a Professor Lewin video, and you can see, yeah, there's nothing. All the comments are gone, all the recommended. And at first when it did it, I didn't even get the video, but now at least the video shows, but nothing else. And I can't, on my own channel, let's go to that if I can. Very strange, really. I got rid of cookies. I got rid of all the cached crap. I cleaned the browser as best I could and reinstalled. And I almost couldn't re-sign into my account because this is what I get. When I say subscriptions, this is the page I get. So this is my subscriptions. I do get the comments, so I can still read comments. But yeah, the subscription page is gone. And, just very strange. So I don't know if anybody else is having issues with Firefox. So there's so few people watching these videos, it doesn't make much sense to ask anybody. But I'm curious what the difference between what a private window actually does. I mean, can it block an IP address? I've never tested it. So I'm just wondering whether YouTube is just fucking with my IP address, and that's why this is broken. It seems to work in Opera. I don't have that on this computer. Better, but then you can't play some of the videos, which is weird. So, it just, I don't know. It's one of these quirky things. You just say this kind of shit shouldn't happen, blah, 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 blah. And when it happens, it's just like, well, what's the excuse for it? I mean, what the fuck? It's a basic function. It's a web page. It should display. I mean, it's not that complicated. It really isn't that complicated. Anyway, so if anybody has any insight, I'd appreciate it. But anyway, so we really don't need any of this crap anyway to do what I have to do. So let me get rid of that. Alright, so now on to the subject. Alright, so there's this idea in physics, okay, that this kinetic energy thing happens, that some sort of real energy, that this squared function. Now, even though, we go over all these different kinds of experiments that kind of indicate, man, there's something wrong with the theory, right? I mean, it just can't quite work out, because you can't explain things. And so the Dispar's lab guy actually uses this clip from a video where I point out that, you know, you can take a 5 mass and you can add 5 mass to it. All right, and you end up with a 10 mass, and it ends up going 1/2 the velocity. So the 10 mass goes at 5 velocity, and this was going at 10 velocity. And the momentum is perfectly conserved. I mean, when the experiment's done, it's almost, you know, you're talking about 99%, because you can do it really carefully. And as I pointed out, you know, really carefully means you can combine these two things without using any energy at all, in the sense that if you just lightly drop this thing, just a tiny little millimeter, you're combining them without causing any loss in velocity this way, because the energy you're using to combine them is in the opposite direction. So that's very handy. So anyway, you can get this huge percentage, you know, almost a perfect experiment in some respects, you could argue. Sorry about that. And the simple argument is you've lost 1/2 the kinetic energy is gone. Okay, so the KE you had here is now you've lost 1/2 of it. A half. It's a huge amount. Half the total energy of the object is now gone. And the simple argument is I can't say that, you know, pieces flew off, because that would be the same as a bowling ball hitting a pin. If a piece flew off, I have to use my momentum. I can't keep all my momentum and make things move. So we know I couldn't have knocked pieces off. And I can't make a whole bunch of heat, because heat also uses your momentum. If you have friction and you heat a surface and you're rubbing it and you're heating the surface, you have to lose momentum. You can't heat something and keep your momentum. You can't have it both ways. You can't keep your force and convert your force into heat. So it seems so obvious that this can't be true. 1/2 the energy disappeared in some form that didn't use hardly any momentum. I mean, 1% momentum loss, okay, and somehow that equals 50% of your kinetic energy. It doesn't make any sense. All right, so you know something fishy's going on. All right, and then I pointed out other experiments that are just as glaring. So you take a ballistic pendulum and you say, okay, let's capture you know, the energy of a bullet in a gun. All right, so you take a big heavy thing and you shoot a little tiny bullet into it, and you're trying to capture the linear motion. So the idea is the bullet will penetrate and it'll be rubbed against, and the fact is it's going to cause the energy to do some of this. Okay, and the slower the bullet's going, the more likely it is it's going to be pushing clay in very undesirable directions. So you know you're going to get some clay is going to pop out this way. You know, you're going to cause some deformation in the clay molecules. You're going to be moving around, and that all of their motion won't end in this direction. So some loss of direction. So yeah, the experiment comes out pretty much as you'd expect, in the sense that, okay, I have a certain momentum going in, say 100, and I'm only going to have 97 coming out. So we'll just use that as a percentage. I'll conserve 97% of the momentum. So most of the momentum will be converted into the big heavy thing moving in this direction with a proportional velocity to losing 3% of its energy, its momentum. Now the kinetic energy thing is completely screwed up. 2,000 joules go in and 1 joule comes out. 1. Okay, 1. So you lost 99, as Professor Lewin did the experiment, 0.94% of the kinetic energy. Now what am I going to say? I only have 3% of the momentum to move clay. So the moving in clay can only use 3% of my momentum, yet it accounts for 99.94% of the kinetic energy is gone. This is a paradox. You can't just sit there and say, okay, there's 1900 joules, 1900 watts of heat. and I only used 3% of the momentum to make 1900 watts of heat. You can't believe that's true. You can't believe that only 3% of the momentum makes 1900 watts. Then the total joules going in would have to be an insanely high number. 200,000 watts. The bullet didn't have 200,000 watts. It had 2,000 watts going in. That equaled 100% momentum. You still have 97% of the momentum. How the hell could you make 1999 actually? Yeah, so, sorry, my mistake. 1999 watts of heat and only use 3%. You can make all that friction and you didn't slow the bullet down at all. I mean, you didn't slow the conversion of the energy into linear motion of the big heavy object. So it's paradoxical, it's nonsensical, it can't be rationally explained because it hasn't been, nobody's done it, nobody will do it, and it's gigantic. Okay, so now we're to the real the experiment they're doing. So I've talked about different experiments and they choose their own. Okay, so the idea is we have this pendulum experiment, which I can demonstrate to some extent. With this little Newton's cradle. So the simple argument is if I hit it with one thing, the same energy I put in comes out, and then it obviously reverses for free. So if it was theoretically a better Newton's cradle, this could go on for a minute or two or 10 or whatever, right? It would just keep doing this. And what's it doing? Well, it obviously is reversing the direction completely, right? I mean, and there's no energy loss or gain. So it goes in going this way, and it comes out going that way, and then it goes back the other way again. So obviously switching directions is almost free, theoretically. All right, and then so their theory is that if I tied these three together and then did the experiment again, these three will pop out with 150% of the momentum that thing had. So instead of 100 in, 100 out, I put 100 in, I get 150 out this way, and I get 50 back out this way. So now I have twice the total motion in the universe. I have an object going 150, I have an object going 50, and now they're going to collide again. And their theory is that half the energy, half the momentum disappears, and now we get the 100 back out. Come on. That is problematic, to say the least. All right, so that's the basic experiment. So you're really just saying, okay, we're going to do an experiment. We're going to crash a 1 into a 3 mass. And that's supposed to get us these numbers where I put 100 in, okay, and I get 150 out, plus 50 back this way for a total of 200 momentums. And then they come back together and I will get 100 out. So that's the experiment. Now what he's done is put little sticks on here and a timing gate and to measure velocities. And but what he hasn't done is all the logical things you say. Is first measure the distance of your pendulum, never hurts. Have a standard place you lift it to, so you're always doing it from the same exact height. So just put the pendulum up on a block or something with the same position and you just pull it out or do something so you can get a reliable swing. And then measure the velocity of your reliable swing. I mean, put your timing gate in here and just measure with the fastest velocity you can find by moving it. And then you'll know exactly what your going in momentum is. And then you can try to measure your going out momentums, but whatever. So he doesn't do anything like these standard things, these things you would think would be sensible things to do. And so instead, he tries to put the timing gates, in positions where they're going to measure the initial motion of both of these objects. Okay, the coming in thing and then the going out thing. And the problem is that this is going to decelerate when it hits this one. You can understand that, right? It's going to be going as fast as it can. It's the highest V plus. And then it's going to start going slower and slower and slower till it gets to a 0, and then it goes backwards. So obviously this deceleration part you don't want to measure. You want to measure just the highest velocity, not the decelerating velocity. And it seems obvious that that's what he's done. All right, so so the first thing I do, you have a standard way of putting the energy in that's reliable. Test it a few times. Now that's the other thing. He did this experiment done poorly 80 times. He's very proud that he did 80 trials. What moron would do 80 trials of a simple experiment? You get the same answer 5 times in a row, you know, okay, it's working. Because there's no hidden variables here. This isn't like hitting the nucleus of an atom where it only happens 1 in 500 trials. This is something where the variables are always the same. There's no unique variable. There's no anything. So as long as you're getting the same answer 5 times, you know, yeah, okay, that's the answer. And what you would really want to do is move these timing gates. You'd want to make sure you're getting peak velocities. Okay, so you'd move this timing gate a little bit this way to make sure that you're not measuring the deceleration and you're measuring the peak velocity. But it didn't do that. So he didn't spend any extra trials just moving things just a tiny little bit. Okay, nope, didn't do that. All right, so it's the same pattern. They just create the experiment, they rig it to work their way. Now let's understand, physicist Michael was supposed to do this. You know, he got nice, you know, steel bangables, built himself a Newton's cradle, and said he tried the experiment and it was a little too heavy, so his cradle apparently wobbled a little or did something, but no evidence of what the results were at all. So, you know, he sort of has a little bit on the line in the sense that he is a doctorate of physics, and so he really can't publish garbage experiments, you know, ones that at least he knows are garbage. So I would argue that the reason why we saw nothing is because, yeah, it wasn't working his way. That's the reason. And, you know, and there's no other reason. He didn't get the results he wanted. And so this is just about engineering experiments to come out the way you want them to. And the defects are obvious. So in this case, I'm just going to point out an obvious defect. Okay, it's like so obvious you say, okay, you know you're doing something wrong right from the first trial. So these are the numbers I wrote down. Okay, over here. When I watched a couple of trials, I just watched, you know, and I said, okay, what are the numbers? So let's see if I can. I should be able to move that up a little. Okay. And you just look at them and you say, okay, this must be, okay, this number must be the initial velocity. This is probably the energy of the thing coming back, and this is the energy of the thing going forward. Now, the obvious thing you can say is you say, okay, 0.078. If I double that number, I'm going to get 156. Right? Okay. That's higher than either one of these numbers, right? So they can't actually produce more than twice, you know, more than half the velocity. So if they're moving more than half the velocity, you know something must be wrong, because that's free energy even by their kinetic energy theory. That's too much kinetic energy. So you're already saying this is fail, okay, because this number can't be right. It's impossible for it to be right because you're creating too much kinetic energy. Clearly you're violating momentum all over the place, but I just mean the kinetic energy part doesn't even work. It's like me saying that this Newton's cradle. So we're saying he never showed his working. So he never did the simple experiment of just say, okay, here it is. Here's the experiment. Bonk, 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 bonk. And show us how long it would bounce. Right? See, this goes pretty good with just 2. Right? I mean, that's pretty good. It goes for quite a while. So he didn't even show that. You know, didn't even show us how much it loses. Now, obviously, when I add more, it runs out much quicker, right? So if I do 2, yeah, it doesn't last too long. So we lose quite a bit of energy per impact. So you know you can't gain energy per impact. You can't gain kinetic energy from these impacts, because then the thing would go even faster and faster and faster, right? It wouldn't be losing energy, it'd be gaining energy. And we know it loses energy per impact. It can't gain energy. So we know these numbers have to be higher than this number doubled. They have to be. It has to go something less than half the speed. It can't go half the speed. It's impossible for that to be right. So we know this number sucks. And we know the obvious fault is that he's got this timing gate just a little bit too close. And what he's really measuring is the deceleration. He's measuring when it's just hitting it and then slowing down because it hit it. So he's measuring the deceleration. He's not measuring it at its peak velocity. And again, all I had to do to correct for that was to move this timing gate a little bit that way. Did he try it? No. Maybe he did. Maybe he did, right? So that's always the argument are these phony results, these bad results, these errors, are they on purpose? Or are they an accident? I think it's a valid question. Now, he did a tipping a bottle thing over, and he wouldn't repeat it the right way. And he did it based on 2 pendulum swings, right? So one pendulum is swinging, a total arc, let's say, of that. And the other pendulum is swinging a total arc of this, okay? And he puts the bottle in the same place. So, I mean, obviously, the one that has this big arc is going to hit the bottle when it still has a lot of energy. And the one with the little arc is going to be almost out of energy when it hits the bottle. So he wouldn't even do that experiment, honestly. All right, so then on top of this, the previous experiment he did, okay, so we'll just go to that. That I wasn't even going to comment on it, so bad. All right, so we've been over the whole friction thing, that a rolling object, this is the truth, okay? Galileo discovered this. It's not a hidden, it's not some new revealed truth that if I have one velocity and I have a 2 velocity and I have something that seems pretty fair, all right, I'm just going to roll them, that the 1 velocity only goes 1/4 of the distance that the 2 velocity goes. Now, that looks like 4 times the work, but the simple argument is this is the same time, 1 unit of time, as this is. And we all know that gravity is a time-dependent force. So obviously, in 1 second, this got, like if this was rain falling, you could understand if the rain's falling at a constant rate, all right, and this goes through the rain quickly, it's going to collect a lot less rain per inch or foot. And this, because it's moving very slowly now, is going to collect more rain per inch or foot. And so the total wetness, if I did this experiment with wetness, we know this will be the outcome. We know that this is going to be the same amount of wet that this is going to be. Now, if I did it with photons, and I just measured, I've had a light source, a constant light source, and I was just going to measure, I have a little thing, a little photodiode, and I just move it here, and I decline the speed at this rate, that is, it's 1/2 the velocity here, that I'll get exactly those same results. That is, I'll see if there's 50 photons here, there's going to be 50 photons here. 50 raindrops here, 50 raindrops in this little spot, 50 raindrops here. But this is exactly the same as this. And this is obviously a lot less stuff happening per inch because of the faster velocity. So I've already explained this at least 20 times, right? I've drawn this at least 20 times. And so then he does an experiment. So with that pointed out, okay, he does an experiment, what was it, proofs, okay, he's going to proof it. He's banging his little matchbox cars, okay, and he puts a spring on them for some reason. Now you say, why would you put a spring on it? You want it to stick, okay, so he's going to push a wooden block with the car. And so he's going to do a 1 velocity and then a 2 velocity. Now we know the car all by itself is going to do this, 1 to 4 thing, okay, because of gravity and what Galileo proved 400 years ago. So we already know what the car itself would do. But of course the wooden block is doing the same thing. It's in the same force coming down. It's going to have the same resistance to motion based on velocity. It's going to have the same friction coefficient essentially. And it's going to do exactly the same thing. 1 velocity will get you 1 unit of distance. and 2 velocities are going to get you 4 units of distance, and it's going to be the same ratio. You're going to do 3 units in 1 unit of time, and you're going to do 1 unit in 1 unit of time. Same outcome, and it's just mimicking gravity. This is what gravity does, okay? You drop something 4 times the height. It only takes twice the time. 4 times the height, twice the time. So, I mean, these are already known facts. So, I mean, there's no point in even commenting on the experiment, because I've already pointed out why this won't work. You can't do this. All right, and if you're going to do it, you need something frictionless. Okay, you need a surface that produces no friction, and then you measure the velocities. But you can't do it on a frictioned surface. If there's any friction, the friction takes the energy. As the energy is being taken, okay, the fact is it's going to take it unevenly. It's going to take very little here, and it's going to take a lot here. That's the way friction works. The slower you go, the more friction. The faster you go, the less friction. I don't even know how people don't even understand this. I mean, you really can't understand that if you go really fast across a surface, that you really don't have much contact with the surface. So, what can I say? It's just so bad, that they just keep making these arguments with they won't counter any of these paradoxes and explain them away at all. Explain how this really is, this linear friction thing really happens, that this is the same work as this is, that those 3 units are producing the same heat into the ground. How could they believe that? It only lost half the velocity. The times are perfectly symmetrical. But this is what you're stuck with. And so let's just understand, just to be clear on this pendulum thing. I mean, the consequence of them having this free momentum theory is that somehow this great secret has been hidden from all of the people who need to use a jackhammer or any other device. I mean, they're basically saying I take a small item going fast, okay, let's say 15 for the fun of it, and I bang it into a big object, and I can double that 15. That is, I can increase the momentum by keeping a big percentage of the velocity. Well, let's just keep with this 150 thing. So I go from a 1 mass to a 3 mass. Okay, so I start off with 100 momentum. I hit the 3 mass, I have 150. And then if I hit a 6 mass, all right, no, I have to hit a 9 mass. All right, then I'll gain another. I'll again increase the 150 to 3/4 of 150, right? So I'll gain another 100, so I'll have 250 here. And I'll just keep increasing the momentum if I can keep hitting a heavier weight. But the simple truth would be this means that if a wrecking ball is going to hit into a building, that every crane would have 2 wrecking balls. It would move 1 wrecking ball, okay, a small one. It would lift that one up, have it hit into another wrecking ball, okay, and increase its momentum by anywhere from 150% to 200%. And if I make this bigger, much bigger, I can increase this to 200. So I'll gain 200%. So I go in with 100. This will leave with 200 momentum. So this simple example where, lots of wrecking balls do this. They don't swing the weight. They just pull it and then let it swing. And so every time you're using that procedure, the sensible thing to do would be have a heavier weight suspended, bang your weight into it, and have that now hit the building, and you'll get twice as the effect. Twice the momentum will hit the building. That's their theory. And they're actually saying that the building is absorbing 4x the momentum. That's what they're actually saying, which is absolutely nonsense. So anyway, I mean, the theory has an implication in the sense that lots of things could use the theory, okay, to maximize the energy output. And we don't see any examples of it being, of this amplification process being used, where you can amplify the momentum by merely banging light things into heavy things. It works with anything. Any light thing I bang into a heavy thing, I automatically get more momentum. Doesn't matter. Doesn't matter even the ratio. I always get more. Maybe not 200%, but I'll get more every single time by their theory. And then they say, I'm not allowed to say, I really don't think you're doing something. I'm saying, if your experiment is saying you can do this free momentum thing, I'm saying there's good reason to think it might be flawed. And then there's double good reason when you miss even obvious things, like the fact that your number is way off. That it's not possible that the objects are moving faster than half the speed. The theory, the momentum theory, says they have to be going a quarter of the speed, but the point remains, you can't make free kinetic energy either. Okay, free momentum is bad, free kinetic energy is worse. So you already know something's wrong with your experiment, and yet you're saying you proved it. I don't think you proved it. All right. So let's see. Is that enough? I mean, there's so many examples. The thin ice example. I mean, they just keep playing games. You know, like the simple argument isn't the faster you go across the thin ice, the less time you have spent putting pressure on the ice, and the ice hasn't received your full weight. Your full mass has not been converted into gravity. Gravity hasn't had enough time to push you into the ice. And therefore you're not putting as much pressure on the ice because gravity hasn't had enough time to push you into the ice. And they're saying that's not true. That's not a logical argument. I think it's profoundly logical, and they need substantial reasoning to defeat it, not just vague little mush statements. All right, so back to, I might as well do this one stupid comment, because somebody did this on the website. They posted this crap about the Eddington experiment. Search for modern Eddington experiment 2004. Looks like someone will carry the experiment, whatever that means, in April 8th in light of many of the same objections that you have arrived at. So the fact is that NASA's actually going to give the amateur guy funding. And I don't know, I mean, he's talking as if there should be maybe 10 or 12 of these different people doing the experiment, and somehow they're going to share their data. So little telescopes taking bad pictures, they're going to share a bunch of bad pictures. Now, the irony of this, if NASA actually is funding any of this stuff, you've got to ask the question, right? Why don't they just do it from space? It's 400 times better resolution, and they don't need an eclipse of any kind. No eclipse necessary. They can do it now. They can do it tomorrow. They can do it anytime they want to. Anytime. I mean, obviously the sun has to be, available, but it's usually there. The sun's pretty consistent. You don't have to make an appointment. I mean, so this is the bullshit. You're just saying you can't smell this as garbage and junk and propaganda and nonsense. Why the hell would NASA be wasting money financing a way of doing the experiment that's 400 times less effective? And that's if you have a perfect eclipse. That is, if you don't have any cloud cover, like Eddington did. Eddington only got 10% of the data quality, 10% of what he was expecting. 10%. That's one, just a tiny, 1%. I mean, just 10%. I mean, it's a terrible degrade. 90% of the data ruined. Okay, so a huge degrade. And you got 400% better seeing from space. 400%. And then Eddington's telescope was a 12-inch telescope, and they're using, their, household telescopes. So NASA's not funding it from some observatory doing the experiment. Now, on all the eclipses there have been, What is the argument? That no observatory, there was never an eclipse over an observatory? I don't believe that's true. I think Mount Washington actually was right in line with the perfect 12 noon perfect weather eclipse of 2017. So why they didn't do it, I have no clue. I'm just saying it is suspicious, isn't it? Isn't there some point where you people will acknowledge that is junky science? That doesn't make any sense. It's not rational. It's not reasonable. Why would you repeat the experiment in a way that has 400 times degrade in the quality of the experiment? 400 times less effective. Like the fog is 400 times thicker. 400 times. Why would you even bother doing the experiment from Earth? 400 times. I mean, how... And you don't see that you people are just completely disingenuous. That there's no way I can believe you aren't fanatic lunatics if you won't acknowledge that does stink. That doesn't make any sense. It takes 5 minutes from space. It costs $5 from space. And that's literally what it costs, frankly. I mean, it's such a nothing. I mean, all the satellites with cameras with nice, decent telephoto lenses on them. You can even use Jupiter. You don't even have to look at the sun. You could use Jupiter, for fuck's sake, because of that 400 times improved seeing. And we're supposed to believe they didn't think of it. It's 400 times better doing it from space, but they didn't think of that as being, well, yeah, maybe we should do it from space, huh? Take advantage of that 400 times better resolution. And you're telling me you honestly think that's good science? That's credible science. That's what you would expect from science, is when there's a chance to do the experiment 400 times more precisely, you don't bother. Why would you do that? Why would you do an experiment 400 times more precisely? What advantage could that possibly create? How would that enhance credibility any? You did the experiment with 400 times better seeing. How would that make the experiment more credible? And you're honestly going to look me in the fucking goddamn eye and tell me you think that's good science? If you were a scientist, that would be how you would do science. You would say, oh, fuck doing the 400 times better resolution experiment. Let's do it with cardboard boxes. And some paper mache. The fuck you would. If your life, if it was going to cure your wife's cancer or your kid's cancer, you sure as hell would be pretty goddamn pissed off that they're not using the 400 times better technology. Right? If you had some skin in this fucking game that science is playing, if something that you cared about was dependent on it, you sure as fuck wouldn't want them to do it the 400 times worse way. The 400 times more painful way. Oh, you're just such duplicitous pieces of shit that you can't even admit that this is shitty science. You're just proving you're religious fucking fanatics, okay? You don't give a fuck about the truth, and all you're out for is to attack the dissident, and especially this particular dissident, for whatever fucking stupid, petty, small-penised reason. You're all just such little petty pieces of crap. There, my statement is on the record. I've defined you as what you are. Okay, and the future will know you for who you are.